And welcome one and all. Mr. Callen here to help you out with another day of volume. So let's get to it, shall we? First of all, if you're in Mr. Callen's Math Lab class, let's take 5 to 10 minutes, complete the math review, week 2728W. Come on back when you're ready to check your answers. Press pause if you need to. Ladies and gents, I'm going to ask you to spot the mistake or mistakes. I put the S in parentheses. There is at least one mistake up here, so don't just copy something that you don't understand. Go ahead and take time, analyze your answers with mine, spot the mistake or mistakes, press pause. Come on back when you're ready for our lesson. All right, ladies and gents, another day of volume. Let's go ahead and review the first page. Pause, check your answers. Come on back when you're ready for the second page. And here's the second page. You know I love questions. Please bring those questions in coming days. But for now, let's go ahead to volume 3, which should look something like, well, that would show you the answers. So assignment for today, volume 3, we're going to do a few of these together. I'll probably do just what I did on the previous day. I'll do some of the problems with you, and then you'll do the rest on your own and or with partners. So let's take a look. I'm going to do all the evens today. Number 2, here we go. First things first, what is the figure? Does it have curves? Does it have edges? Well, this has edges. Is it a prism? Is it a pyramid? Well, this has two bases, a top and a bottom. I've colored them in. And it's surrounded by rectangles. Therefore, we have a prism. To find the volume of any prism, we multiply the area of the base times its height. And I don't know about you, but I quickly see the height is 6 centimeters tall. Now, area of the base is no joke. Some of you will come off to the side and you're going to draw a new triangle. In which case this side is 11, this side is 8, this side is 12, and the guy in the middle is 7.1. But guess what? To find the area of a triangle, we need only its base and its height. That means we'll need the 12 and we'll need the 7 and 1/10. Multiply 12 and 7 and 1/10, and then take half of it to get an area of 42 and 6/10. Now I'm going to go ahead and multiply 42 and 6/10 times 6, 255 and 6/10 cubic centimeters. After all, what are we measuring? Key question for the next couple weeks. How can we use measurement to help us describe real-world objects? If we're looking to fill a three-dimensional space, then you can bet it should be a three-dimensional units. Onward to number 4. All right, here we go. What kind of shape is it? Does it have curves? Does it have edges? This guy's got curves. So is it a cylinder, cone, or sphere? Oh, that's a cylinder, Mr. Cowan. Looking at my handy-dandy formula sheet, I found the volume of a cylinder to be pi times radius squared times height, in which we're going to find the area of that green base, but then we're going to stack it 10 kilometers tall. Now I look at that green base and I ask myself, is this 10 kilometers a radius or a diameter? Oh, that goes all the way across. So if all we want is the radius, we're going to take that diameter and we're going to cut it into 2 parts. And therefore a single radius in this case is going to be 5. So multiplying pi times 5 times 5 times 10, rounding it to the nearest hundredths place, it is closest to 40. Don't just write 0.4, that would be the nearest tenth. And of course, kilometers times another kilometers would be cubic kilometers. Onward to number 6. Okay, does it have curves? Does it have edges? Again, nice part about videos, folks, if you need to, pause, rewind, go back. Fast forward if it's too easy for you. Ask yourself, how are these problems similar? How are they different? Number 6 is more like number 2 than number 4 because it's got edges. But it is not a prism. It is a pyramid. It is one and only one base surrounded by several rectangles, and therefore we need to make sure we have this 1/3. Now I can quickly see that height is 6 miles tall. But the area of that base, there it is again. We got another triangular base here. So I'm going to redraw it off to the side. If you don't want to, you don't have to. I notice we got a 6 here, we got a 10 here, we got an 8 here. We don't need that 10. Remember, to find the area of a triangle, we're going to take the full rectangle and then cut it in half. Therefore, all we need is the 6 by 8, which is 48. Cut it in half, which is 24, and that being our base, we can substitute that in. Now we'll go ahead and take 1/3 of 24, which is 8. 8 times 6 is 48 cubic miles. Again, if you need to, pause, rewind, copy down what you need, and then we continue onward. Number 8, curves or edges. Oh, number 8's got some curves. Is it a cylinder? Is it a sphere? Is it a cone? It's a cone. So we're going to take the cylinder that surrounds it, pi times radius squared, and we are then going to cut it into thirds. Now I can quickly see the height is 20. Let's take a look at this green base. Let's take a look at this red measurement that appears to, 10 centimeters is the radius. Don't cut it in half. Don't double it. 10 is the radius. So if we go to our handy dandy calculator, multiply 1/3 times pi times 10 times 10 times 20. That is what that 10 squared means. We multiply that, round it to the nearest hundredths place, 2,094 and 40 hundredths cubic centimeters. Again, pause if you need to. Otherwise, we proceed. Number 10. Does it have curves? Does it have edge? Oh, this has got curves. It is a sphere, and our formula sheet says to find the volume of any sphere, we're going to multiply 4/3 times pi times radius times radius times radius for a 3-dimensional volume. But I quickly see that this measurement of 13 2/10 goes all the way across. So let's go ahead and divide it into 2 parts. If we were to divide 13 2/10 into 2 parts, we would get a measurement of 6 6/10 centimeters for each radius. So we multiply 4/3 times pi times 6 6/10 cubed. Again, use your power button on a calculator, or you can just multiply 4/3 times pi times 6 6/10 times 6 6/10 times 1/3 6 6/10. Final answer is going to be 1,204 and 26 hundredths cubic centimeters. Now, ladies and gents, I'm going to do something interesting. Again, if you need to pause, rewind, go back, I'm going to show you all the answers. After all, for a completed assignment, you got to show the work anyways. But before you do, pause and reflect. How are all these problems similar? How are they different? Sure, they're different shapes. They're different dimensions. But how are they similar? Number 1, you got to figure out what is the shape. Number 2, write the formula down for that 3-dimensional figure. Number 3, substitute in the dimensions for each figure. Being very careful, a big B is an area of a base, and a R is a radius, not a diameter. Number 4, step 4 is to compute. You have calculator if it's an appropriate tool, or simply use mental arithmetic if you can. Last but not least, number 5, check your units because we're asking for volume. How many cubes of ice fill that freezer? So, before I continue on, just a reminder, with 5 minutes left in class, write down the 1 or 2 most important things that you must know to find volume. That could include a mistake that you made. That could include coloring in the bases. That could include that big B area of the base, whatever it is. Make sure you summarize your learning. Now, if you need to, pause, go to your homework, come on back when you're ready to check answers for the first page. We already did the right side, so let's focus on the left, shall we? And let's check the second page as well. Remember, for a completed assignment, you must show work, ladies and gents. It is not good enough just to show my answers. And here we go. So I would like you to check yourself, to check your answers, to see what makes sense, to see what questions you have. Work together, bring some questions for me when I'm back. And that's what I got for today, ladies and gentlemen. Take care, do well, and let's grow.